They built monuments so precise that modern engineers still struggle to explain them. Granite cut cleaner than any steel tool should allow. Stones weighing tens of tons placed with millimeter accuracy. Structures aligned to the stars with mathematical perfection. These incredible achievements were accomplished more than 4,000 years ago, without iron tools, electricity, or modern machines. The question that refuses to disappear is simple, yet unsettling. Did ancient Egypt possess technologies that were later lost to time? Welcome to Misteryo Archives, unlocking the secrets of time. Today, we're uncovering the lost technologies of ancient Egypt, exploring how one of humanity's earliest civilizations achieved feats of engineering, chemistry, mathematics, and logistics that continue to challenge modern understanding. Ancient Egyptian civilization emerged along the Nile River around 3100 BCE, when Upper and Lower Egypt were unified under King Narmer. Over the next 3,000 years, Egypt developed into one of the most stable and enduring civilizations in history. Its power wasn't just built on religion or kingship, but on technical mastery. Knowledge passed through generations of craftsmen, architects, engineers, and priests whose practical skills literally shaped the physical world. Nowhere is this more evident than on the Giza Plateau, constructed during the 4th dynasty between roughly 2580 and 2490 BCE. The Great Pyramid of Khufu once stood 146.6 meters tall and consisted of approximately 2.3 million limestone and granite blocks, some weighing more than 70 tons. Archaeological excavations led by Dr. Mark Lehner have revealed worker villages, food production sites, and skeletal remains that confirm these monuments were built by organized, skilled laborers rather than slaves. Yet while the human effort is well documented, the methods remain partially obscure. Granite, one of the hardest natural stones on Earth, appears throughout Egypt's most important structures, especially in temples and burial chambers. At sites like Giza, Saqqara, and Aswan, granite blocks show cuts of astonishing precision. Perfectly flat surfaces, sharp internal corners, and symmetry accurate to fractions of a millimeter. This is incredibly difficult to reconcile with copper tools, which were softer than granite itself and represented the most advanced metal technology available to Egypt before iron appeared around 1000 BCE. Some of the most striking examples are found in the Valley Temple of Khafre and the Serapeum of Saqqara, where massive granite sarcophagi weigh up to 100 tons each. Engineer Christopher Dunn conducted precision measurements on these surfaces and noted tolerances comparable to those produced by modern industrial machining. Traditional explanations argue that copper saws combined with quartz sand abrasives could eventually achieve such results through sheer labor and time. However, no surviving tools or workshops have ever been found that match the scale and consistency implied by the finished work. This mystery deepens when we examine core drilling evidence. In the late 19th century, the famous British archaeologist Sir William Flinders Petrie discovered granite cores at Giza bearing spiral striations. After measuring them, Petrie concluded that the drilling rates implied pressure and speed far beyond what hand-powered tools should reasonably achieve. Modern experimental archaeology has tried to replicate these markings using bow drills and abrasive sand, but the results have been inconsistent and often fail to match the original core samples. While none of this proves the existence of advanced machines, it does reveal a clear technological gap, an area where the evidence survives, but the explanation remains incomplete. Transporting stone posed another enormous challenge. At Aswan, the unfinished obelisk, abandoned around 1400 BCE during the reign of Queen Hatshepsut, still lies in the quarry. Had it been completed, it would have weighed approximately 1,200 tons. Its mere presence proves that ancient Egyptian quarrying capabilities surpassed anything attempted until the modern era. How did they move such massive objects? Reliefs from Deir el-Bahri depict colossal statues being hauled on wooden sledges, with workers pouring water onto sand to reduce friction. This method was experimentally confirmed in 2014 by physicists at the University of Amsterdam, validating the Egyptians' advanced understanding of applied physics. But while horizontal transport is better understood, Vertical lifting remains an unresolved puzzle. Stones weighing tens of tons were raised to heights exceeding 40 meters with extraordinary placement accuracy, all without pulleys, cranes, or counterweight systems clearly documented in surviving records. The surveying accuracy adds another layer to the mystery. The Great Pyramid is aligned to true north with an error margin of just 0.05 degrees. That's more precise than many modern buildings constructed with laser instruments. Egyptologist Kate Spence proposed that this alignment was achieved using stellar observation, specifically the simultaneous transit of the stars Kochab and Mizar around 2500 BCE. This theory fits well with known Egyptian astronomical traditions and religious beliefs that linked the pharaoh directly to the stars. The pyramid's proportions further suggest an advanced understanding of geometry. The ratio of its perimeter to its height closely approximates 2p, leading some researchers to argue that the builders encoded mathematical constants directly into the design. Mainstream scholars caution that this may reflect symbolic geometry rather than deliberate calculation. But even achieving symbolic consistency on such a massive scale requires remarkable planning and precision. Egyptian technological sophistication extended beyond stone and geometry into chemistry and materials science. By 2600 BCE, Egyptian artisans had created Egyptian blue, the world's very first synthetic pigment. Modern analysis shows it required kiln temperatures between 850 and 1000 degrees Celsius, indicating precise thermal control. Even more surprising, Egyptian blue emits infrared radiation, a property now being studied for use in medical imaging and solar technology, an accidental discovery thousands of years ahead of its time. Their metalworking also reveals lost expertise. Copper tools found at excavation sites often show a hardness inconsistent with pure copper, suggesting advanced alloying or work-hardening techniques not fully explained by surviving texts. Bronze metallurgy emerged by around 2000 BCE. And although iron would arrive much later, Egyptian craftsmen clearly maximized the potential of the materials available to them. Mechanical knowledge, while largely invisible in the archaeological record, is hinted at through devices like the shadaf, a counterweighted water-lifting tool used as early as 1500 BCE. Later developments, such as the Sakia water wheel, demonstrate increasing mechanical efficiency in irrigation. While no Egyptian gear mechanisms survive, the existence of the Antikythera mechanism in Greece around 100 BCE proves that ancient civilizations were capable of complex mechanical systems when the right knowledge and materials aligned. So where did all this knowledge go? Some theories suggest that much of Egypt's practical expertise was transmitted orally rather than recorded in permanent texts. This would explain why these advanced techniques vanished during periods of upheaval. Egypt endured multiple disruptions, including the Persian conquest in 525 BCE, Greek and Roman occupation, religious transformation, and the eventual loss of hieroglyphic literacy by the 4th century CE. With the disappearance of the practitioners, the knowledge faded, even as the magnificent monuments remained. Fringe claims of lost super technologies, like electricity, sound levitation, or even alien intervention, are not supported by any verified evidence. The so-called Dendera light reliefs, for example, are widely interpreted by Egyptologists as symbolic religious imagery associated with creation myths and the Djed pillar. But rejecting fringe ideas does not diminish the genuine mystery of how much practical expertise has truly been lost to time. What remains undeniable is that ancient Egypt possessed exceptional craftsmanship, advanced mathematics, precise astronomical knowledge, logistical mastery, and chemical innovation far beyond what was once assumed. Their monuments are not mysteries because they defy reality, but because they demonstrate what human ingenuity can achieve and how easily that knowledge can vanish. Stone endures. Knowledge does not always survive. This is the Misteryo Archives, unlocking the secrets of time. The past shapes the world we live in today. If this story made you see history differently, like the video, share it with a fellow explorer of time, and join the conversation below. Subscribe to Misteryo Archives and help preserve the stories that built our world.